Okay, so in this video, we're gonna look at translations. It starts on page 21 of the packet. It actually goes to 23. Okay, so first thing, what is the translation? So translation is pretty much we're sliding the figure over. It is an example in isometry. Remember, in isometry means that the image and the pre-image are congruent, and they are in a translation. If you slide something, you don't change the sides of it. And when you do a translation, we need a directional arrow or a vector to define the translation. And we'll mostly be using vectors. So for vectors, there's two ways to write it. One is they write a capital T to indicate translation, and then they use these triangular brackets with the first number being the X value, how much you move left or right, and the second number being the Y value, how much you move up and down. And it works just like the coordinate planes. Like if it's negative, you move left. And if X is positive, you move right. If Y is negative, you move down. And if Y is positive, you move up. So it would be like T3 -2 is one way that they would write it. And so that's saying that I'm gonna slide my image like 3 to the right. So we move each point 3 to the right. And then 2 down. And the other way to write it, which we use a lot in the packet, is they do X, Y, and they put an arrow, and then they're gonna put X like plus or minus a number, and then Y plus or minus a number. So like doing the same one, it would look like X plus 3 and Y minus 2, which again means we move each point 3 right and then down 2. So these are the two different notations that are used on the homework and in the packet. So we are going to do a few of the examples, and then the other ones, if we have time in class, we'll do it as a breakout room. If not, you can just kind of try them on your own, and if you want me to check them, just let me know. So we're using this design one again, and we're going to translate it so that it's X plus 4, Y plus 2. So again, that means this plus 4 means I'm moving right 4, and the plus 2, the Y, means I'm moving up 2, and I'm doing that to each point. You can also write it as a vector. So a vector is kind of like array, but it has a specific endpoint. So it starts at A and then the vector goes to B, and you put an arrow to show the direction, but we're not saying that it keeps going in this direction. We're saying it stops at B. And so you can see this vector is that it goes to the right 4 and then up 2, and this is where it ends. So when I do my slide is that every point you should be able to connect B to B prime, and it should look like this directional arrow, this vector. Okay, so we're going to do this for each point and translate it. So I'm going to start with A, and I'm going to go 4 right. So 1, 2, 3, 4, and then up 2, and count up 2, 1, 2, and that would be my new A. And so this is A prime. Okay, and then I find those points, which is 6, 4. Now, you don't have to use the graph. You could use this and then point it just by adding. So each time the X, I add what it says to the X. So I'm going to add 4. So 2 plus 4 is 6. And each time to the Y, I'm going to add what they say to the Y, which is 2. So 8 plus 2 is 10. So B prime, it should be at 6, 10. And again, you could also count it and go 1, 2, 3, 4, and then 1, 2. And you should also be there. And then I can connect those. So I'm going to do the same thing with C. C, I'm going to add 4 to 5, which is 9, and add 2 to 8, which is 10. And so C is at 9, 10. And this is my C prime. And again, you could from C count 4 to the right and up 2, and you get the same place. Okay, so D, if I do the counting method first, I would go 4 to the right, 1, 2, 3, 4. And then up 2, 1, 2, and this would be D. And if I just check the coordinates, I should be at 9, 7, which I'm at 9 and then 7. So that's right. Okay, so E, I find it easier to add first and then check it, but it's completely up to you which order you do. So E, 4 plus 4 is 8. 5 plus 2 is 7. I'm just going to do each one. So F, 4 plus 4 is 8. 7 plus 2 is 9. G, 3 plus 4 is 7. 7 plus 2 is 9. And then H is the last one. 3 plus 4 is 7. And 2 plus 2 is 4. Okay, so then I'm going to plot them. So E is at 8, 7, that's E prime. F prime is at 8, 9. G prime is at 7, 9. And then H prime is at 7, 4. Okay, so that's my point. It's translated. Like I said, if for the arrow, if you connected like A to A prime and drew an arrow from A to A prime stopping there, it should look like that directional vector that we had here, where you go over 4 and then up 2, which it does. And that should be for each point. And says, number 2 says, what do you notice about the translation of the graph in terms of ordered pairs? And it's exactly the same as the vector. So we added 4 to the X coordinate and 2 to the Y. And again, it's that, I mean, they gave it this to us, but X plus 2, Y plus 2, that's the vector. So we're saying like X, Y is changing to X plus 4 to Y plus 2. So there is number 3, which is another practice. It's the same thing. So you can try it with this vector. They even tell you how to move, which most of the homeworks won't. You do have to know how to move from there. But we're going to look at number 4, which kind of combines two transformations that we did. So we're going to explore a glide reflection, which is a slip and flip, slide and flip. So these are, again, isometries. The size is not going to change. In fact, any combination of transformations that are isometries will result in isometry. To do this, we need a directional arrow or a vector to define the translation and a line of reflection. So we're using this design 1. We're going to translate it X plus 1, Y minus 3. And again, they tell you, but you should be able to figure this out just from that 1 to the right and 3 down. Or by the vector shown below. So this vector is showing me I'm going 3 down and 1 to the right. And then we're going to reflect that image over X equals 2. Okay, and we're going to complete the table below. So we have to do both things before we write the image point. So you can like make a separate table and add the 1 and subtract the 3 if that's the way you prefer to do it. But don't make sure that your final answer is not just from the transformation. You also have to reflect it. So for X plus 1, Y minus 3, I'm going to move each point 1 to the right and down 3. So A, I'm going to be 1 to the right, down 3. And that's going to be my new A prime. H, 1 to the right, down 3. B, 1 to the right, down 3. C, 1 to the right, down 3. Okay, I'm doing this for each point. Okay, F, same thing. G. And then I did H. Okay, so that's my new image translated. And then after the translation with the glide reflection, then I also reflect it. So I'm going to reflect across X equals 2. Remember, X equals 2 is a vertical line going through the X coordinate of 2. So I'm going to draw this vertical line at X equals 2, and I'm going to flip everything over my one that I slid. So the translation one, I'm doing that new figure, the blue one, over this line. So again, we count to the line and count the other side. So B prime is 1 away. And I usually just do 2 primes to indicate my final answer. You can not and just not put letters until the end. It's just up to you. Okay, so C is 1, 2, 3, 4. So I count 1, 2, 3, 4. And that would be where C is gonna land. A is 1 away. Okay, H is 1, 2. Okay, D is 1, 2, 3, 4. So then I count 1, 2, 3, 4. E is 1, 2, 3. And so I count 1, 2, 3 on the other side of the line. Okay, G is 2 away. So then I'm going to go 2 away for G. And F is 1, 2, 3. So 1, 2, 3. And then this is my final image. And then I'm going to write these points down. So A is at 1, -1, or A double prime. Okay, H is at 0, -1. Some of these are hard to tell just because of all the drawings. Okay, B is at 1, 5. C is at -2, 5. D is at -2, 2. Okay, E is here, which is at -1, 2. Okay, F is also at -1, but then 4. And then G is my last one. So G double prime is at 0 and then 4. Okay, so that's how you do a glide reflection. You first translate it and then you flip it or reflect it. Okay, always do the translation first and then the reflection. Okay. So the last problem is some of them are going to ask you to find the vector. And the main thing is you just need to make sure that you start with the pre-image, which is the one without the apostrophes, and then you count to the image. So I'm going to start at C. And I'm going to say, okay, how do I get from C to C prime? And I want to start with going left or right. So to go left or right, I'd have to go left. If I count, it's 1, 2, 3, 4, 5, 6. So I have to go left 6. So I'm going to put that as -6. And I have to go down 2, which is -2. So there's 2 ways to write this. The one way is that notation they used in the other problems, which they would say X, Y. And then they would do X -6 because I went 6 to the left, and Y -2 because I went down 2. Or you could use that vector notation where you put T to stand for translation and then put -6, -2. Okay, so that's how you do the translations.